All right, go ahead.
Okay. Hello, everyone. We're the cartographers, and this is the Cisco Wi-Fi visualization project. So this is what we look like. We're all doing software development, but we're just going to go over like the additional roles we're taking on. I'm basically the point of contact between us and our clients and sales team.
Yeah. I'm the project manager, making sure all of us are busy with work.
And I'm kind of like the system architect.
Great. All right. So, Dr. Oliver, do you mind reading this to me?
Wi-Fi visualization. What is that?
I thought you knew already. I'll tell you. So basically, Cisco is developing this Wi-Fi sensing technology wherein they are using these special routers and analyzing the refraction of the electromagnetic waves generated by them in order to create point cloud data. And this 3D point cloud data can be used to analyze motion. And our assignment is to basically visualize this 3D point cloud data in a creative way. So this point cloud data isn't perfect necessarily, just by nature of how it's being collected. There's a lot of noise. So that means there might be some cluster of points that represents a person, but there's also just a bunch of random points in space that aren't a person, and we don't want to consider those. So there's going to have to be a lot of additional calculations done in the visualization in order to deal with this noise. And additionally, we're going to want to do some kind of clustering well, that means basically putting points together into similar objects, and you'll see why that's important in later slides as we go over the use cases. So our goals and objectives basically are to do all the boring stuff really well, like documentation and testing and stuff, so our development goes more smoothly throughout the quarter, and we don't have to spend a lot of time figuring out what's going on. We could just have something easy to look back on, and obviously we want something working by the end of the quarter. So next slide. So now we're just going to talk about clients and stakeholders who we're doing this for. So this is Dr. David Malouf. He's a distinguished engineer at Cisco. Used to be like a lead scientist at NASA. He wrote a book. He's a pretty cool guy. And stakeholders. So this is where we start to understand the use cases of our tool and the features we might want to implement and how we want to implement them in order to make it useful to them. So the example that was given to us was this patient down case, which basically means in a hospital or a retirement home, people fall and they can't get up. And we want to deal with that in a way that doesn't require constant patrolling and monitoring of their rooms. And this technology is a very useful way to do that because it preserves patient privacy. You don't actually have to see who it is. You don't have to have cameras monitoring every single room and have someone monitoring those. And additionally, you don't have to have employees of the hospital walking around constantly monitoring all the rooms. You can just instantly see, oh, someone's fallen here. We have to go send someone. Another use is entertainment. This is a sort of similar technology to the Xbox Kinect, if you guys are familiar with that. Or basically you could use your body as the game controller. So there might be an application where you could like wear a VR headset and use your body as the controller if you want to do that. We're not really going to focus on that, but it's fun to think about. And additionally, there's uses in transportation. I know I've been very frustrated with how airplanes board people in the past and how people don't really follow the rules on boarding buses. So this could be used to sort of analyze those situations because, as you might know, like planes and buses are already like implementing Wi-Fi networks on them. So this would just be a very easy implementation, and the companies could analyze how people board these vehicles, where they sit, and yeah, it'd be useful for that case. So This is our persona. This is based on the hospital case. I'm sure you guys have already heard the story of him. His name is David. He's 38 years old, and after getting his medical degree and working as a big shot doctor in the city for many years, he decided to go back to his roots and return to his small rural hometown where a lot of old people live for some reason. Now, he wanted to give back to the community, and the best way he figured he could do that is to open up a home for the retired. Now, as you may know, retired people tend to be old. So, they fall down. And when they fall down, it's not good. Everyone on track? Okay. So, he doesn't have a lot of money for this retirement home. It's a small town, so most of the people are living in the home. There's not a lot of employees. And he just doesn't have the money to hire them, and people are falling down constantly. And he can't have people monitoring the freaking retirement home all the time, so he wants to implement this Wi-Fi sensing technology in order to detect instantly when people fall down and send a highly trained employee to help them. And basically, looking at this guy helped us identify one of the main implementations of our tool, or one of the main implementation details of our tool, which is that we want it to be a web app, because if a regular person is using this, it might be easier for them to just access a website than to download some heavy OpenGL application, and we'll go more into detail with that later. Yeah, so just boiling down all these customer stakeholder requirements into more technical things. We need to visualize point cloud data in unique ways. It's going to be stored in CSV files. It's going to be streaming from a Wi-Fi network in real time. It needs to be good resolution so people can tell what's going on. And additionally, there needs to be noise handling so the picture is clear. And Celestine is going to formalize some of these in the customer requirements.
That's my trademark. So we were looking at the requirements through a customer lens and an engineering lens for our assignment. So first, for customer requirements, what our stakeholders would want. We broke it down to 3: data processing, event like identification and classification, and then noise adjustment. So for data processing, we're dealing with a lot of points, and we don't necessarily know what the room looks like either. So we're talking about 500 to 700 data vectors per second, and each data vector has like 7 fields, the location and also the velocities for like X, Y, Z, and a surface area associated with it. So there's a lot of data coming in, and right now we're given files and we're just processing those, but then like Braden said, eventually we want it to be real-time processing. So those are some of them. And then for events, these are 2 events that we were focusing on, the falling down case that he mentioned and collisions potentially too. And lastly, for noise adjustment, being able to minimize noise, but also being able to adjust that level if you want to, if the user wants to, and then also providing statistics on the noise characters. And then for engineering requirements, basically like those, but just more technical and more quantified. So for clustering is a useful way in which we can identify events as well as like also noise. So clustering, we plan on using both location and like if points, a collection of points have similar velocities associated with them in a given time frame. So we plan on using that. And then there's a few based on noise filtering and metrics. And yeah. And then this is our design fan. So we're kind of working right to left. Right is more functionality, so we'd like to have a noise filter, again, like event identification, clustering, and we'll be using these tools. And then moving to the left as we go on to next quarter, we want to be able to visualize them. Right now it's all local and application-based, but we want to start moving it over to a web-based application so it's more user-friendly. And then when we have time, doing our UI stuff and adding more functionality to that. And then this is our decision matrix. So the features that we were focusing on were accessibility to make it more user-friendly to the user, performance as we input more, or as it deals with a lot more data, can it handle that, and also not just reading from a file, but doing it real time. And then scalability, right now we're just kind of visualizing points in space and not really looking at velocities yet. So once we start adding more features in, can we scale it more? And then feature depth, as we add more features, can it still perform to the capacity that we want it to? And then cost, because we're for college students. But I feel like Cisco won't have that problem, so it's okay. Yeah, and then we were looking at Direct3D, OpenGL, WebGL, and MVPython. And we really liked OpenGL, WebGL.
Yeah, so right now I'm going to talk about the logistics stuff. And here's what we planned to do. Basically the timelines we have for these 2 quarters. And in the first couple of months, we did a lot of research and design development. So we try out a couple libraries and we come up with different prototypes. And then here's where we are. We try to implement the actual visualizations tool. And then after we have the basic structure, we're trying to get down to the deeper level, which is data and analytics. So we want to handle noise, we want to handle all sort of user inputs, thresholds. So we need to come up with a good data structure for it. And then at the end, try to get nice looking user interface tools. And now is question time.
So you mentioned that this is on specialized Cisco routers. Is the technology that sources the CSV files you mentioned, or the user project, limited to proprietary Cisco hardware software, or is it, to your knowledge, something that might easily be implemented in a sufficiently capable router that supports Cisco to use?
So in regards to a lot of the actual implementation of the generation of the point cloud data, we basically know nothing. We've asked a lot of questions, but David is very coy about how it actually works. Like we tried to ask him details about how it's collected in order to try to understand better how to visualize it, but he's like, no, that's not important. So we don't really know.
Well, part of the ambiguity, we asked him to, like, oh, we have reason to believe that, like, haven't you also started starting your own visualization projects on this and like tried it out? And they have, but the reason for the ambiguity is like maybe they feel like they've been pinholed, like their creativity. So he's hoping that with us knowing less, we can think outside of the box more, because there is no box to begin.
It'd be funny if the point cloud was just a cow.
Yeah. Have you got any insight into why Cisco wants this? Like the retirement home thing, I don't know if that would be
Yeah,
I mean, money-wise, right? I don't know how big the retirement industry is.
Sorry, asking about like real stakeholders.
Yeah.
They wouldn't tell us that either.
How accurate is the data that you're getting? Like, what does it look like? Do you get just like a blob of where a person might be, or is it applying to?
Yeah, so
We'll show you in a minute.
so far they haven't sent us any real data generated by the router, I think. It's just like
A controlled test.
yeah, it's like generated point clouds from like 3D animations. So
So do you have a plan for like your testing phase to test off these like 3D point clouds, or are you planning to like get it down to an actual unit at that time of the project?
Right now, not really, but I feel like we'll break it down going back to this one. So we'll probably break it up into these 3, and so like the cluster, like the event identification, will probably be easy. Like, oh, did you identify an event or not? It could be yes, no. Then it could be more specific as we go in. But yeah, it'll be broken down to like these 3 categories.
Did that answer your question, or were you asking more about connecting to the actual device?
Yeah, I was kind of curious about yeah, actually going to be using like the end device for the final testing.
Yeah.
Like, folder, anything.
I think he did mention getting us out there and actually trying out the router. But throughout our main development, I think we're just going to be working off the files. So we have to make sure that our visualization is decoupled from how the data is being fed into it. So once we do that, it's pretty easy.
Okay. Time for demo?